Can you solve this geometry challenge? Here's the question. Given the circle, let's insert 4 identical squares having an area of 16 square units. And the question is, what is the area of the circle? Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so to answer this question, take note that those squares is perfectly tangent to our circle. Alright, so to answer this question, we need 4 squares. And here it is. The first one, the second, the third, and the fourth square. Now, since the area of this square is 16 square units, so it follows that the length of the side of the square must be equal to 4 units. So this is 4, this is 4, this is also 4. Now, let's call this segment, small segment, be equal to x. And since the whole thing must be equal to 4, so the remaining segment must be equal to 4 minus x. Alright, and the rest of the side of the square must be equal to 4. Now, to find the area of the circle, what we're going to do is to get the value of this variable x first. And to do that, we will use this concept, the secant power theorem. So it says, given 2 secant segments which share an endpoint outside the circle, this is the endpoint outside the circle, the product of one secant segment and its external segment is equal to the product of the other secant segment and its external segment. So given this figure, I provide another figure. So we can say that PA, this PA multiplied by PB must be equal to PC multiplied by PB. Alright, so using this concept, we can now solve for the value of this variable x. Now, let's do that. So, we have here external segment, which is 4 minus x, multiply the whole secant segment, which is 4 plus 4 plus 4 plus 4, which is equal to 16. So, we have 4 minus x multiplied by 16. And we have the external segment, which is 4, multiplied by the whole secant segment, which is 4 plus 4 simply equal to 8. So, we have 4 times 8. Now, using this equation, we can now solve for the value of x. So, let's do that. Let's distribute the 16 to 4 and negative x. If we do that, we get 64 minus 16x. And 4 times 8, this will give us 32. And then, let's subtract 64 on both sides. 32 minus 64, this will give us negative 32. Now, divide both sides by negative 16. So, x equals negative 32 over negative 16, or simply equal to just positive 2. So, using secant power theorem, we get that this x must be equal to 2. So, we can replace this x with 2. Now, from this point, or simply the chord of this circle, the length of this chord must be equal to 4 plus 4 plus 4 plus 2. Or simply equal to 14 units. And also, we know this side length is also equal to 4, 4, and 4. And the length of this chord of this circle must be equal to 4 plus 4 plus 4, simply equal to 12 units. Now, I see a right triangle. So where it is, let's connect this endpoint and this point. If we do that, we get a right triangle. And this hypotenuse must be the of this circle because this is a right triangle. And since it is a so the length of this must be equal to twice the radius because the length of the diagonal is twice its radius. So this is 2r. Now, we can now solve for the value of the radius of the circle. And finally, we get the area of the circle. And to do that, let's use the Pythagorean theorem. So we have 2r raised to the power of 2 equals 12 squared plus 14 squared. Now, 2r raised to the power of 2, this will give us 4r squared. 12 squared is just 144. 14 squared is just 196. And 144 plus 196, this is just 340. Now, divide both sides by 4. So, we get that the value of r squared must be equal to 340 over 4 or simply equal to 85. Now, we know the value of r squared. And we know that the area of the circle can be computed using this formula, pi r squared. We know the value of r squared. This is just 85. So we can replace this r squared with 85. So we can say that the area of this circle must be equal to 85 times pi square units. And there you go. This is the area of this circle. And using this figure, we can say that its area must be equal to 85 times pi square units. And as always, we are done.